Hello guys, welcome to Samaliaki YouTube channels, and today we are going to learn about passive filters. What is passive filters? Passive filters, we say these are the electronic devices which allow some signal to pass and block other signals. This is example of passive filters whereby we have the input signals and output signals, and examples of signals can be frequency or whatever. Now we have to find the voltage gain. Voltage gain is equal to voltage output over voltage input, this one over this one, and this one it is also called functional transfer function, so it is denoted by function transfer. Yeah, so we have this filter circuit. As I said, we said is a circuit which allow a certain amount of signal frequency to pass while blocking other frequencies or signals. We have the basic three types of filters, whereby we have low filters, passive, high, and band filters. So now let us start with low pass filters. As it is named, these are the types of filters which allow only low signal to pass and block high signals. Examples, frequency, examples of those signals. And a good example of this low filters is RC. As you can see, this is our circuit. We have the input here. We have also the output, but we have the resistance, and this is capacitor. This is reactance. This is the resistance of capacitor. It is denoted by ZC. This one, reactance. Yeah. Also, so if you want now to find voltage gain, you will take V out over V in, as you can see here. But if now you want to find voltage output, you use the potential divider to get the voltage output. This one, this over this plus this one times V in. This is potential divider. You use the potential divider to get this one. But what to note here, we know this is the reactance of the capacitors is equal to, it is 1 over WC, we know. But also we have, this is what we call J, which is a complex function. So now you can substitute here, and then from voltage output is equal to ZC, this one, over this one plus this one times V in. But we know the value of ZC, this one, reactance. You can substitute, and the purpose of doing this one is to find the transfer function or voltage output, voltage gain. So voltage gain is equal to voltage output over V in, which is equal to function transfer, and it is denoted by this formula after substituting this data here. Now let's move to the high pass filters. High pass filter, we say these high pass filters is the types of filter which allow only high signal to pass and block low signal. And a good example of this high pass filter is CR circuit. You can see this is C, this is R, and this is output and input. But we know the resistance offered by this capacitor is ZC, and this is normal. Now you can also find voltage gain. Voltage gain, we know it is voltage output over voltage input, this one. So you can substitute to obtain this data here. So you will use the potential divider also to obtain voltage output, but so it will be V gain, voltage gain is equal to voltage output over voltage input, which is equal to, we know now, we can substitute because we know this data, which is equal to R over R plus 1 over JWC. This is a function complex. So you will obtain, and this all is equal to transfer function. Then after knowing that one, we can move to the other forms. We can also use inductors, capacitors, and the resistance, as you can see here, to represent the low filters and the high filters. So here, this is inductor, this is resistance. Now you can find also the voltage gain, because we know voltage gain is equal to gain, voltage output over voltage input, this one. So voltage gain is equal to V, this one over this one. But we know if you want to find voltage output, you use the potential divider. So V output is equal to, now you can check here, this is R over R plus L, this one, times V in, this one. So divide by this one, V in, both sides, V in. So voltage output over voltage input is equal to R over R plus L, and this all is equal to transfer function. This is for the case of low pass filters. For the case of high pass filter, this one, for the case of high pass filters, you can see here. So to find voltage gain, it will be voltage gain V output over V input. But we know what is voltage output here. This is voltage output. You can obtain by using the potential divider, because here there is a junction. So voltage output is equal to L over R plus L times V in. Now divide by V in to obtain gain. Voltage output over voltage in is equal to L over R plus L, which is equal to transfer function, this one. Then after obtaining these ones, now we can check the graphs of high and low. As you can see here, have the graphs of low pass filter and high pass filter. And this one is cutoff frequency, this one, cutoff frequency. And we have the definition of cutoff frequency here, so you can read and understand more. These are the graphs of high, low, and high. Also, we have now let's finalize by studying the band pass filters. What is band pass filters? Is the combination of high and low. As you can see here, we have this one and this one. We have this one and this one. So it is the combination of high and low. You can also find the transfer function. Transfer function, it will be, you will take this of this and this one and this one. As you can see here, this is the general formula, but you substitute to find this one, because you know it is this one and this one, this one and this one. So for the first it is this one, for the second this one, it is this one. So you can substitute and obtain this transfer function. Then after there, we have also the graphs of band pass filters. This is a graph. It means here we have a pass filter is the combination of high and low. So it will just allow a certain and block a certain. We have several networks of filters, where we have T network and pi network. This one, as you can see here, it is a T network. These are impedance. This one impedance. So you can see here. But what to note, if ZA is equal to ZB, we see the circuit is balanced and it is divided by a half. But if they are not equal, we say this circuit is not balanced. Now you can check for the case of pi. This is a pi. This is a pi. Has the form of pi. Now you can check the more examples of T network and pi network, but not this formula. This and this one you can use later. For example, now for the case of high, this is for the case of high network. Low filters in difference network. This is, you can see here. Now assume if it is balanced, we use this formula. But for the case of high pass filter for a T network, it is capacitor and capacitor. We have inductor here. So you use also, this is cutoff frequency, not this formula, and this is what we call nominal. I have summarized here so that you can take. This is a very simple and clear summary. This is for low pass filter. This one, for low pass filter, cutoff frequency is denoted by this formula, and nominal impedance is this one. High pass filter, this is cutoff frequency, and this is nominal impedance. Now you can be asked to find, these are sample questions. For low pass filter, find the value of L and C. You just substitute the formula here. For example, I can show here. This one we have, that is FC, cutoff frequency is equal to 1 over pi, then LC. So you can make the subject, this is FC square is equal to 1 over pi square, then LC. You can choose make C the subject if you want to find C, but I'm talking for the case of low. So it will be FC square pi square, then L is equal to 1 over C. Now you can reciprocate C is equal to 1 over FC pi square L, this one. Now you can refer to the formula because you know what is this one. Make here the subject. This is equation 1. If you refer here, that is R nominal impedance is equal to L over C. This one, just make R square is equal to L over C. So also you can make C the subject and substitute here to obtain L. So it is R naught square over L is equal to 1 over C. Reciprocate. So C is equal to L over R square. Now this is equation 3. You can equate now to obtain L. So it will be, that is this one, C is equal to 1 over frequency pi square L, which is equal to also L over R naught square. Now this is 1 over F C square pi square L is equal to L over this one square. Now make L the subject. So that is the value of L. So you can also use for this low and high to find L and C. Thank you very much, guys, for watching my channel. Don't forget to subscribe, like, comment, and share. You are most welcome to Sir Myliak YouTube channel.